Hey everybody, this is Dr. Jacobs. I had a little bit of a family emergency that I needed to go take care of, so I won't be in person in class today. I did create this video though for you so that we don't get behind in our lectures. So you'll want to make sure that you watch this video because we will pick up where we leave off when we go into class on Friday. So make sure you use our class time today to go through this video. All right, so last time we talked about that the hypothesis testing steps that we're learning are basically the recipe for what we're going to be doing for each of these future weeks. So when we looked at the first step is basically deciding which type of statistical analysis that we're going to use. And so for this, I taught you 4 different things that we'll typically ask ourselves when we're going to choose which statistical analysis we're going to use. That was, what is the goal for the analysis? What level of measurement are the variables? A lot of times we're going to be looking specifically at the dependent variable, although that may change depending on which statistical analysis we're doing. You also want to know how many samples or how many groups are you testing and what the goal is, and did we use a between group, a within group, or matched group design. So when we're looking at this, we want to make sure that we're reviewing all that information that we've had up to this point in the semester, so that we make sure that we are able to do the things that are going to be required of us now. And there's going to be a lot of critical thinking that's involved with that. I told the class, so if you weren't here on Monday, I told the class that it's really, really, really important that you're able to determine which statistical analysis to use. If you're going to be in my research methods class in the fall, then you're going to want to make sure that you're really paying attention to when we use certain statistical analyses and these other steps that I'm going to teach you. So this brings us on to kind of an outline of the different types of statistical analyses that we usually cover in a first statistics class. One of those include the one sample z-test, which we will learn in the very next unit. Another one is a one sample t-test. I'm not going to teach that one to you, but we'll talk about it a little bit when we learn about our one sample z-test. We're going to learn something called the independent samples t-test. And we're also going to learn the dependent samples t-test. So it'll be really important that you're able to distinguish between those two because the differences are really, really subtle. And so we'll see that when we get into a little bit more of these analyses. We're also going to learn something called the one-way analysis of variance. And that's going to be a really tough one that we're going to learn. That's probably going to be our toughest that we'll learn this semester. There's also a factorial ANOVA. I'm not going to get into that, I think, this year, but that's a more complicated version of the one-way ANOVA, basically. We're going to also learn the Pearson product moment correlation. So if you have ever heard anyone say anything about correlations or items are correlated, typically they probably use some sort of correlation. The most common kind of those correlations is the Pearson product moment correlation. Then we're going to use that as a springboard to learn more about linear regression. And then the last one, if we have time this year, I'll teach you, and that'll be the chi-square for goodness of fit. And that is actually the only non-parametric analysis. So if you have not watched the video for Monday and you weren't in class on Monday, you'll want to make sure that you watch that video first and then go through this one. All right, step 2, after we figure out which analysis that we're going to do, we're going to go ahead and write our research and null hypotheses. So typically if I ask students, what's a hypothesis? They drone in unison, it's an educated guess. And that's not exactly it. I mean, it is an educated guess, but there's so much more that go into research and null hypotheses that we don't think about. All right, so when we look at these hypotheses, we are running these hypothesis testing steps in order to answer a research question. And we went over this a little bit on Monday, that our research question is what we're trying to find the answer to as researchers. And so we'll have whatever research question we have. I think the one that I gave on Monday was, do the suicide warning signs predict suicide attempts? And so that would be a research question, and our research question will be either answered best by the research hypothesis or best by the null hypothesis. These are the only 2 potential answers that we can have to a research question. All right, so when we write our research and null hypothesis, we're going to write these in symbols and in words. A lot of times it's a lot easier to start out by writing them in symbols first and then translate those symbols into words. Okay, so these two types of hypotheses are complete opposite explanations of one another, and you cannot, whatever results we get from running the hypothesis testing steps, you cannot have both at one time. You'll have one or the other will be the best explanation for what's going on with our data set. Okay, so again, it's a research and null hypothesis. Our symbol for research hypothesis will be capital H sub 1 and then a colon. So you'll want to put that on your handy dandy symbol sheet right now. You can pause me if you need to do that. And then our symbol for the null hypothesis will be capital H sub 0 and then a big colon. And if you remember previously, we learned that whenever we have sub symbols, they typically tell us something more about the larger symbol that we have. And so when we have H sub 0, another word for null is what? Another word for null is 0 or the absence. So it makes sense when we look at that symbol because we have the big H and then we have sub 0 to reference that it's the null hypothesis. So when we write our research and our null hypotheses, there are typically two different ways that we can do this. We can write these hypotheses directionally, or we can write them non-directionally. So when we choose to write one of our hypotheses directionally, we also must write the other directionally as well. So however you write your research hypothesis, if you write directionally, the null has to be directionally. If you write your research hypothesis non-directionally, then you'll also have to write your null hypothesis non-directionally. They are a pair, they are a couple. So you have to write them the same way. Okay. And you can choose to write them either directionally or non-directionally. There will be some exceptions to this rule when we get to some more advanced analyses, but if there's ever an exception, I will let you know, and we'll talk about it in depth so that you can remember it. So again, I'm going to keep repeating this. So if I keep repeating that to you, it probably means it's super important. So you want to remember that if you write one directionally, you will also write the other directionally. And the way that we write hypotheses directionally or non-directionally typically come off of previous research. It depends on which research question you specifically have. So for example, if I want to see if people who eat chocolate every day are significantly happier than people who do not eat chocolate every day, if I think that they're going to be happier, if we think they're going to be significantly greater than the other group, then that means I'm going to write my hypotheses directionally. Now, if I have no idea which group would be higher, if for example, if we think, is there just a significant difference between people who in happiness of people who eat chocolate every day and those who do not eat chocolate every day, then that would be a non-directional hypothesis. So when we have our research question, it'll give us those details. So if our research question is saying, is there a significant difference between these two groups? We know that we're not showing that there's any sort of direction in there. We're just saying, is there a difference somewhere? And so that would be non-directional. But if we say that one group is greater than or one group is less than the other group, that's when we write our hypotheses directionally. All right. So usually, though, we want to write these hypotheses directionally if we can, if at all possible. We aren't going over quite why yet, just trust me for now, but eventually we will get into the explanation for this. And I can go ahead and sneak you the answer now, even though it might not mean much yet. If we write them directionally, we're increasing the power of our test, which basically means something that I'm not going to tell you yet. We'll get there though. So again, our hypotheses can be written two ways. Non-directionally, we think that there might be a difference, but we don't know where the direction that difference is. And so we showed that with the example with if we were just seeing if there's significant differences between people who eat chocolate every day and those who don't, and their levels of happiness. So directionally, we write our hypotheses directionally when we have an idea about the direction of difference. So if I wanted to do some sort of study on some psychopharmaceutical, let's say an antidepressant, if I want to know if that antidepressant works, right, if we're a big pharmaceutical company, we have an idea that our treatment group, the ones who get the antidepressant, would have significantly less depression, hopefully, in our eyes, than the group that got the sugar pill or the placebo, right? So if we have that type of research question. Does the antidepressant reduce depression in comparison to the group who gets the placebo? We know that we're going to say that the group taking the antidepressant has significantly less, right, which is a direction, than our placebo group. So that would be a directional hypothesis. So again, I'm going to keep saying this over and over and over again. It's going to be the new, what is a scale question, or what are your levels of measurement? If you write your research hypothesis directionally, you also have to write your null hypothesis directionally. No matter how many times I say this, we're still going to have students that struggle with this. And that's okay. You know, we all struggle when we're learning some new things. And so we'll work through that a little bit as we move through these different units. So again, if you write your research hypothesis non-directionally, you'll also want to write your null hypothesis non-directionally. This would be a really good question for me to test you all on the exam. I could write a sample research hypothesis and make you select the proper null hypothesis. That would be a great way for me to test if you remember this information or not. Okay, so directional versus non-directional hypotheses. Non-directional hypotheses use something called two-tailed test. So when we refer to hypotheses, we refer to them as written non-directionally or directionally. When we're talking about the actual statistical analysis, however, we will either identify it as a two-tailed test, which is non-directional, or a one-tailed test, which means we wrote a directional hypothesis. This will make a lot more sense once we get to the step where we draw out our normal curve, and when we put the tails on our actual normal curve, you'll be able to see it and imagine it a lot better. So again, non-directional hypotheses, they use these two-tailed tests, and this just says that there are significant differences between groups. We don't know what direction at all. And then in our directional hypotheses, as you can guess, and I've told you already, we're going to use one-tailed tests for these. And this is where we say that either one group is higher than the other group or one group is less than the other group. And this all goes right back into our research question, okay? Again, the idea about the direction of the hypothesis usually comes from the research. It also may come from whatever you're trying to do with your study, right? So like we did the example of the antidepressant medications, we would, as a pharmaceutical company, really hope that our new drug that we spent millions and billions of dollars on developing would help people reduce their symptoms and severity of depression. Okay. So here I have some examples for you. Again, so I separated these out into two different columns. So we have directional hypotheses used for one-tailed test. You guess which group will have a higher score. So for example of this, the students in my class will have a statistically significant higher mean ACT score than the national mean ACT score. And this is actually something that we could actually test. And this may be what we test in our next unit, because you'd use a one sample z-test to test that. And then when we have non-directional hypotheses, again, we use those for two-tailed tests. Make sure to remember that directional and non-directional connects to the hypotheses. The one or two-tailed test connects to the actual statistic that we're doing. So with the non-directional hypotheses, we do not have an idea about which group will have the higher score. Here, we just indicate that there's a difference. So for example, we could have a research hypothesis that there is a significant difference between the national mean ACT score and the class mean ACT score. And there you see we don't make a difference. So if we're going back and looking at my first one, if I was making this hypothesis in real life, I would venture to say that the students in my class have a higher ACT score than the national mean ACT score. Why do you think that is? You can pause me. You can comment on the side. Why do you think that is? So I would think that because everybody who typically, I mean, this is rapidly changing because of COVID, but everyone who takes the ACT score, not everyone ends up going to college. You all have made it to college. This is I believe, a 3,000 level course, which may indicate that you all are juniors. And I know that we may have some first years, sophomores, and seniors in here as well. But typically, a majority of students who take this class are junior level, which means that not only did you take the ACT score, not only did you consider going to college, you're actually here. And so for me, that would make me think that you all probably would have a higher ACT score than the national mean. And we can test this out. I may collect your all ACT scores this week. So when we write our hypotheses non-directionally in symbols and words, it's a little bit easier than writing them directionally. So let's start with the non-directional first, and then we'll move into the directional hypotheses as well. So non-directional example. So you might want to know if people lose significantly different amounts of weight between the keto and Whole30 diets, but you're not quite sure which diet would be more effective at helping people drop weight in the first month. So you write your hypotheses non-directionally. So to do this, we would take some participants. Let's just say our sample size or n equals 100, and we randomly assign our participants to be either on the keto diet or a Whole30 diet for 1 whole month. And so this means that we would have different participants in each of the conditions. So we have one set of participants in the keto diet condition, and then one set of participants in the Whole30 diet condition. And that means that we're using a between group design. And so if we wanted to do this, we'd actually have to collect data on how much weight each of the participants lost during that 1 month period. And so what would our research question be if we were doing this? So before you move on, just pause this little video and make a guess in your notes like we're in class, like you're shouting out to me in class. So the research question that I wrote, are there significant differences in the amount of weight that people lose in the first month on the keto or Whole30 diets? So what we see here is that we're going to compare the two. So if we're looking at our research question, what is our dependent variable? I'm Dora exploring you all right now, so just shout it out there. Oh man, you're yelling so loud. No, I'm joking. So our dependent variable, the thing that we're measuring, would be the amount of weight people are losing. And our independent variable then would be what? Our independent variable then would be the diet that the people are on. So sometimes people get confused about independent variables. I know that most teachers will define this as what the researcher is manipulating. However, we can use a lot of these statistics using pre-existing groups. So sometimes we're not necessarily manipulating things like we are in this example, but I like to refer to independent variables as the number of groups we're testing. Sometimes you'll hear me, the number of samples we're testing. So we see here we have one independent variable, and that's diet condition. And then, and our independent variable has 2 levels to it, which one of the levels is the keto diet, and the second level is the Whole30 diet. So our symbols for independent variable are capital I, capital V. We may have learned that before. If that is not on your symbol sheet, go ahead and check, and you can pause me while you're doing that to make sure that you have that on there. Our symbol for dependent variable is capital D, capital V, so dependent variable. And then our symbol for levels of the independent variable is lowercase italicized k. So you want to have that in your notes if you don't already. When we move on to some really sophisticated types of analyses like an ANOVA, it's really important to understand the difference between the number of independent variables. So we have one independent variable here with 2 levels to it. Because at some point, and the one that I said was super complicated that we may or may not get to, the factorial ANOVA, you may have more than one independent variable, and that gets really, really tricky because each of those may have different numbers or levels of each of the independent variables. Okay, so after we have our research question, then we need to write out our hypotheses. So if you're going to end up being in my research methods class in the fall, when we are doing some sort of study, we're going to be doing a lot of reading in the scientific literature to see what has already been done in the research, and we're going to develop our own research question from that. So if you see how I have a research question here, and then I'll have you write not just your research question, but what your research hypothesis is and your null hypothesis is in symbols and words. Anytime that we're starting to write these hypotheses, I always suggest to people that we first start with our research hypothesis, because that's the one that we're interested in as researchers. And then after we write that in symbols and words, then moving on to the null hypothesis, because it's just the exact opposite. Okay, so again, typically it's easier to start out by writing them in symbols first and then translating those symbols into words. Okay, so for our research hypothesis, again, H sub 1 stands for the research hypothesis. The capital H stands for hypothesis. Then the sub tells you what type of hypothesis that we're talking about. So for here, we see H sub 1 means it's the first research hypothesis. Sometimes you're going to see the research hypothesis called the alternative hypothesis. And some people are really particular about calling it that. I prefer using H sub 1 because when we get into things like factorial ANOVAs, you will actually have more than one research hypothesis. And if we have them labeled as 1, 2, and 3, that allows us to see and keep track of what our different hypotheses are. So, but if for some reason you saw capital H sub A, you should be able to know that's also something that means research hypothesis or alternative hypothesis. And so I want to make sure that you have both H sub 1, which means first research hypothesis, in your symbol sheet, but I also want you to have capital H sub A as an alternative hypothesis as well. So with these research hypotheses, these change depending on which statistical analysis we're doing. So I'm going to give you all the very basic information, which is going to be most commonly true as we move through these different statistical analyses. And then if anything changes, I will tell you the differences when we get to the particular analysis that might be an exception. So for this, usually there is some sort of statistically significant difference. So that's if we're doing a type of analysis that's looking at significant differences between groups. Usually your research hypothesis is the one that you want to be as the most accurate explanation for your research question. That is most frequently what you want. When we go to test something called our assumptions, that will be an exception to this, and we will get into that into our next step. So then our null hypothesis, our symbol for that again is capital H sub 0. You can see it here. The H again stands for hypothesis. The sub 0 means that this is the null hypothesis. We know that another meaning of the word null means nothing or 0. And so this, I think that this symbol is very intuitive if you're minding what each of the things mean. So here, if our research hypothesis is that there is a statistically significant difference, then for a null hypothesis, it would be that there is not a statistically significant difference. So what we see here is that our research hypothesis and our null hypothesis are complete opposites. So then when we go through and we actually use the formula and plug in the information from our data set, we'll be able to see which one of these is the better explanation for what's going on with our data set. Typically, we don't like our null hypothesis. This is our X that we don't want to talk to anymore. And so usually this is the one that researchers do not want to be the most accurate explanation for our data set when we're trying to figure out what to do during the hypothesis testing steps. Like I said, this will not be necessarily always true. So for example, when we test our assumptions, it'll be the opposite, which sometimes confuses people a little bit. But we'll talk about it and we'll keep going through it till y'all know it. We'll keep rehearsing. Okay, so the research hypothesis in symbols and words, what we'll do is we'll write H sub 1, then we'll put that colon there. You'll see that we have X bar. What does X bar mean again? And that's kind of funny because I said, what does X bar mean? We know that X bar is the sample mean, right? So what we're seeing here is that the sample mean weight loss, so the keto group, is not equal, so we have the not equal sign, to the mean sample weight of the Whole30 group. And so when we see this, we see it's really easy. We have X bar sub keto. Sometimes you'll see numbers there instead of little things. I personally like to write things like keto or W30 so that I can keep track of which group I had first and which one had second. But you may be out there in the real world and see where it says H sub 1 colon X bar sub 1 does not equal X bar sub 2. And all that's saying is the mean of group 1 is not equal to the mean of group 2. Sometimes it can be hard to remember which one you put first. So sometimes I will put different random things here. Oh, sorry. So then we see here we have the research hypothesis. The mean amount of weight people lost on the keto diet in the first month is significantly different than the mean amount of weight people lost on the Whole30 diet in the first month. So what you see here is we took that information that we had in the symbols, and then we translated it into words so that people can actually see. So what we see in here, when we actually write it out as the research hypothesis, we see that there are, that we integrated both the dependent variable and the levels to our independent variable. And so when we do some of these different things, typically as we run through each of the analyses that I'm going to teach you, we will have templates for how to write some of these things out in words. You all saw that in the textbook reading that you had for this unit. And then you'll actually just insert the information from the problem that you're trying to solve. Okay, and then we have our null hypotheses and symbols and words. So what we see here is it's exactly opposite of what we had for some reason it's cutting off all my words on here. Sorry, Google Slides hates me some days, but I can just talk them out for you. So our null hypothesis and symbols and words, we see that H sub 0, we have that colon again. So what we're saying there is, okay, null hypothesis, and here it is. So that colon there is announcing that we're getting ready to tell you what our null hypothesis is. So we have X bar, which is the mean of the keto group, equals the mean of the whole 30 group. So we remember back when we did our research hypothesis, the only thing that really was different was that we had the H sub 1 to show that it was the research hypothesis, and we had the does not equal sign here. So what we see here is whatever we find when we get through our calculations, that we have options for both. Either we're going to have the research hypothesis is going to be the best explanation, or null hypothesis is going to be the best explanation. There's no gray area. There is a right answer. And sometimes that freaks people out a lot about doing statistics, is that there's actually a right answer. But you know, to me, I think that's actually comforting, because sometimes it's nice, because then you can see a lot easier when you've gotten off track and things like that. So when we translate the null hypothesis into words, we see that it's the mean amount of weight people lost on the keto diet in the first month is not significantly different than the mean amount of weight people lost on the Whole30 diet in the first month. That's super wordy. You could actually make this a lot briefer. And typically, you know, no two people are going to write them the same, because we're just interpreting what the symbols are. So the symbols will be the same typically. But when you go to write them in words, there's a whole bunch of different ways that you could say that, and it means the same thing. So here it's a little bit more wordy for you, so you can kind of get the idea that we have both groups. We're looking at the dependent variable, both levels of independent variable. As we move through some of these statistical analyses, though, I will get a little bit briefer, and you saw some of those briefer examples in the reading that you had. So if we tie it all together, if we went ahead and put all these on one page so we can see it, our research question is, are there significant differences in the amount of weight that people lose in the first month on keto or Whole30 diets? We see our research hypothesis says that the mean amount of weight people lost on the keto diet in the first month is significantly different than the mean amount of weight people lost on the Whole30 diet in the first month. And then we have our other answer, that the null hypothesis, the mean amount of weight people lost on the keto diet in the first month, is not significantly different than the mean amount of weight people lost on the Whole30 diet in the first month. So what we see is we have a research question, and then we have our two answers to the research question. And what we'll do is we'll keep going through our hypothesis testing steps, and we will figure out which one of these is the best answer for what we see in our specific sample. So after that, we can write our hypotheses. We can learn to write our hypotheses directionally in symbols and words. So when we're writing our hypotheses, when we're in step 2, you will either write them directionally or you will write them non-directionally. You will not do both for a single problem. You will choose one path or another. And sometimes students get a little confused about that, because I'm throwing so much information at you. So it's pretty common for your head to feel like it's swimming a little bit, and that's normal. We will literally repeat this process every single week for the rest of the semester. So hopefully it won't be as bad for you. So directional example. For example, I expect that after students read my entire statistics textbook, that they should know more about statistics than before they read it. If they don't know more, or they have the same amount of knowledge, then I failed at writing this textbook, and that will break my heart, because it is taking up so much of my life right now. So to test this, I'd probably randomly select a sample of people who purchased my book so that I could test their statistical knowledge using a pre-test before they read the textbook, and then again with a post-test after they read this textbook. So this means that I would have the same participants in the pre-test condition and the post-test condition. So that means that I would have a within group design. So what would our research question be for this? Our research question would be, do the people who read this textbook know more about statistics after reading the entire book than before they read it? So when we go to write our research hypothesis in symbols and words, it's kind of the same way that we did when we wrote them non-directionally. So we see that we have the capital H sub 1, which says research hypothesis. We put the colon to tell people that the research hypothesis is coming. We have X bar and sub post, so that's the mean amount of knowledge people have after reading my textbook. Then we have the greater than sign. So what we see, the difference between the directional and non-directional hypotheses is really what goes right here. So if this would have said does not equal, it would have been a non-directional hypothesis, but we see that we have a greater than sign. We may have some other type of directional hypothesis that uses a less than sign. So if we talk about the example that I used earlier about antidepressants in the treatment group who got the antidepressant having significantly less levels of depression than the group that got the sugar pill, that would also be a directional research hypothesis. So here, so we have the greater than symbol, and then we have the X bar, which means the mean of the sample, and this is the pre, so this is before people read the book. And so when we do this, like I said, I like to write these little sub words or letters down there to help distinguish which sample I'm talking about. And that's really important, especially when we start doing analyses where we have a within group design where we're using the same participants in both conditions or multiple conditions, because it can get really easy to forget which group you put first, which then messes up when we go to do our calculations. So then we have our research hypothesis. The mean amount of statistics knowledge people knew after reading this textbook is significantly larger, or you could use the word greater, than the mean amount of statistics knowledge people knew before reading this textbook. So as a researcher, this is what I would want to see. As a textbook author, this is what I want to see. Whether or not that's true, we'd have to go through the hypothesis testing steps to find out. So then when we go to write our null hypothesis in symbols and words, we see that it's similar. We have the H sub 0 to say null hypothesis. Then we have our colon to say, here comes the null hypothesis. We have the mean of the post-test is less than or equal to the mean of the pre-test group. So something that you'll notice here, when we're working with our null hypotheses, it will either have the greater than or equal symbol, or it'll have the less than or equal to symbol. When we do our research hypothesis, if you see here, that will have the greater than symbol or the less than symbol. And then the null hypothesis, you can't forget that equal part. So that is because if students have the same amount of knowledge before they read my textbook as they did after, then I still didn't do my job. They still didn't learn anything. They had the same amount of knowledge, and that's still not what I want to see. So when we do this, we also see that this covers every potential option that we're going to get from running our hypothesis testing steps. So when we translate that, we see that our null hypothesis, the mean amount of statistics knowledge people knew after reading this textbook, is significantly less than or equal to the mean amount of statistics knowledge people knew before reading the textbook. So if we tie this all together, the research question, do the people who read this textbook know more about statistics after reading the entire book than before reading it? Our research hypothesis, the one that we're actually interested in as researchers, the mean amount of statistics knowledge people knew after reading this textbook is significantly greater than the mean amount of statistics knowledge people knew before reading this textbook. And then our null hypothesis is the complete and utter opposite, right? So our null hypothesis, the mean amount of statistics knowledge people knew after reading this textbook is significantly less than or equal to the mean amount of statistics knowledge people knew before reading this textbook. So when we're doing this, they should all tie together, and it may seem like a lot, but we will keep going over this over and over again so that these get a lot better. for you and a lot easier. And so this is where we're going to leave off for the day. So please let me know if you have any questions about this information and bring those questions to class on Friday. Thank you all for everything, and I'll see you very soon.